I'm Patrick Arlt.
I'm John Gravuel.
And we are going to talk about building applications with the ArcGIS REST JS library and the REST APIs. That is the slide URL. It's got some links to our demos and things in it if you want to get that ahead of time, and we'll put that up at the end. So just a quick agenda. First, we're going to talk a little bit about the what and the why of why you would want to do this. And we're going to kind of get into where we're using it. We're using it in a lot of our apps. And then we'll get into what's changed kind of since last year's talk on this. We'll look at just a couple quick common patterns. And we're hoping to spend most of the time in demos showing you code, various ways that you might think about applying this kind of stuff. So this is an open source library. We host it on GitHub. The code and the doc are open source. We totally welcome contributions, and we've had quite a lot of contributors and new contributors. So this is REST.js is a library that helps you communicate with online and enterprise from a browser and Node. And what that means is we try to handle both a lot of the common use cases, but also a lot of the differences in JavaScript environments and idiosyncrasies with the REST API, and try to provide you with as much support as you can so you can get to those kinds of use cases and scripting either in Node or on a server or in a browser where you might not necessarily want to load the whole JavaScript API. So with some backstory, this is what kind of the most basic requests to the REST API would look like, just with like an XML HTTP request. And it's good to kind of start with this. So there's a URL to the REST API, so sharing REST community users. We're going to get DM Fenton. We add an F equals JSON because we want to get JSON back. We make an XML HTTP. We listen to ready state change. When ready state change is done, we have response text, and then the response text is finally the text of the response. This isn't that great, but it's totally doable. But this is actually how you would make that request from a browser today without any kind of helper code. And you can do the same thing with the newer Fetch API. Again, this is the exact same thing. You've got a user, we're going to post, we need to put the form encoded header, we encode the F equals JSON parameter, we get a promise back, we check if the response is okay. If the response is okay, we can dig out the JSON from that response, and we can continue moving. And there's a little bit of error handling in this one, but compare that kind of the cumbersome kind of vanilla JavaScript examples. That doesn't even cover a lot of the surface. What are all the possible error codes? How do we handle authentication in those requests? How do you encode dates? How do you encode objects? How do you handle tokens for federated servers? How do you refresh the authentication when it expires? That's not even the complete list. There's a lot of stuff that goes into the REST API and working with the REST API that you don't really notice if you're using the JavaScript API. And that's a lot of the stuff that we try to handle for you so your head doesn't explode. Because this is what that same request looks like in REST.js. We have a request method, we give it a URL, we get JSON back. We can catch an error. If it's an auth error, we can handle the auth errors separately from all the other errors. Nice and simple. This does more in less lines of code than all those previous slides. So we try to add as much value as we can. We automatically handle F equals JSON, but we also handle if you want to request images from an image server. If you want to request files that you've uploaded, we can return the binary files to you. We handle all the proper parameter encoding for all the different object types. We automatically allow you to handle uploading files via form data in browsers and in Node. We try to parse out as much of the error handling as we can, separating out the different types of errors from each other. And we also have built-in support for all that authentication and handling tokens for federated servers and refreshing authentication when necessary. So there's a lot of additional value, but it kind of stops at the level of the request. We don't handle anything like mapping or any client-side analysis or any of the things that you would get from the JavaScript API. We just handle the interactions of getting the data into your application, and we kind of pass it off to you right there. So in addition to that single kind of URL parameter, we also accept a whole bunch of other request options along with everything. You can pass any kind of parameters you want. We allow get and post. We use post by default since there are a couple cases where it's a little better. We get asked that quite a bit. There's some methods, there's some additional options for authentication, options for which portal you're looking at, if you want to pass in custom headers, if you want to actually just pass in a complete implementation of the browser's fetch, that's useful in some cases where you might get that from a JavaScript library like Angular or Ember. So we handle a lot of those kind of oddball cases. You can pass in more options if you really need to. So from that single request method, the entire rest of ArcGIS REST JS is kind of built on top of that as a series of packages. So for the geocoding example, under the hood, geocode just calls request. But you can then get lots of nice syntax like just geocode LAX, then deal with the response of that. And you can even just pass additional parameters, geocode LAX for storage true with some authentication. And that'll also just handle it all. But it all builds on top of that single request under the hood. So we have a couple goals for the project. The goal is to work in Node and modern browsers with a small set of polyfills. The goal is to kind of allow those uses to be as slim as possible. We're trying to keep this to under a couple kilobytes, excluding those polyfills. We're trying to be as small as we can for the best load times. We're trying to be framework agnostic. We're not trying to prescribe certain approaches, and we're trying to be friendly with a lot of the frameworks and allow you to kind of work in any way you want. We're trying to keep that roughness of the REST API away from your applications as much. We try to handle a lot of the edge cases and filling in extra parameters where necessary and handling a lot of those idiosyncrasies for you. And then we're trying to align this with the rest of JavaScript. So not only being able to use this in Node, being able to use this with any kind of bundler or framework or any kind of JavaScript tooling that you might want to use. We want to just align with that right out of the box and just work without any sort of fussing or extra implementation or plugins or anything else. We want this to just be drop-in as much as possible. So this is not an official product because it's open source and it's something that we work on in our spare time and we use in a lot of our own applications because we need this kind of functionality and capability. And it started as a way for us to actually just get some sort of standardized version of this that our teams could use together and work on together. And that's why we decided to open source it, because if we're getting so much value out of it, you probably can come up with even more uses for something like this. So a better analogy is this is roughly kind of like the Python API in the sense that it acts as a client to the REST API. The main difference from the Python API is there's no notebooks or kind of Jupyter environment where you can save and rerun your scripts. But the functionality of the code that you're writing is similar to what you get with the Python API. And in that sense, it's very different than the JavaScript API because it doesn't actually do any mapping. It's all just about transactions with the data. There's no client-side analysis. There's no display capabilities. It's just all about interacting with the REST API and bouncing that data back and forth. So I'm going to turn it over to John to talk about kind of what's gone on in this year.
So this project has been around a little bit more than a year. So I don't. Did anybody go to this talk last year, 2018 REST JS? We have a couple. So this has been a really fun one for me. I've been doing open source stuff at Esri for a long time, but I've often kind of taken ownership of orphaned projects or projects that were sort of starting to show a little gray hair. And so to jump in on something right at the beginning has been fun. And I've worked on some predecessor projects. So we had open source projects at Esri before where we did stuff for Node, created Node wrappers, and I've worked on teams that were writing their own implementation to make requests and doing stuff one-off. And I work on the team that makes ArcGIS Hub, so it's the R&D lab in DC. We work on open data and ArcGIS Online as well. And we have, I think we're a team that has open source like in our DNA. But this is an interesting project where our team had already done a lot of this work, and we use Ember primarily as for our front-end application, and we've written a lot of this logic to juggle with items and groups and users in our application. And we open sourced it, and we thought like, God, this is great. We're open sourcing this. People are just going to run and use it. And it didn't. I wouldn't say it was a failure, but it just wasn't a really popular project. The way that we implemented it, it was just a little bit too much overhead for people to pick it up and grab it. So the initial sort of kernel for this project was a collaboration between our team and the team Patrick works on in Portland. They work on developers at ArcGIS.com. We work on hub.arcgis.com. They use Angular and a whole bunch of other stuff. I think their project's as gnarly as any. But we needed to kind of peel back and get things shareable in a smaller nugget so that we could sort of both utilize it in our framework of choice with our tooling of choice. So in 2018, we had done a little collaborating. We had a couple customers jump in and start using it and make contributions to it to make it work for their projects. But it was still pretty early days. There wasn't much functionality. We had a couple packages, and then it just blew up. This year, we've onboarded, I think, almost 30 contributors, which, to give you a comparison, you know, I know that's not hundreds and hundreds, but it's not React, but in the Esri world, the most popular open source project that Esri's ever come up with is Esri Leaflet. It has about 1,000 stars, and it has about 60 contributors, and that's been over the course of 5 years?
5 years.
5 years. So now, in 1 year, we've already onboarded about half of those contributors. And we've seen customers using this, and it's been awesome to walk around the showcase today, and people are cracking their laptop and showing me stuff that they built with this. That's been really cool. But it's also been really interesting, and I think cool, the floodgates opened within Esri of teams. You know, last year we gave the talk and people thought, yeah, that's okay, this is pretty good. I wish I'd have heard about that a couple months ago because I just finished all this stuff and I'm not going to refactor my app to use this now just because. It was like, next time I think I'll use this. And now I feel like we're here, and I think that started actually happening. People started working on new projects and developing new stuff. So the team that's doing story maps and the next generation story maps, they're using REST JS under the hood, and they're finding little bugs and fixing bugs and adding features. The team that works on solutions for local government, utilities, and defense, they do all kinds of content management in ArcGIS Online. They're using REST JS in browser applications as well. ArcGIS Urban's a project that came out of our R&D lab at Zurich. It's about around like land use planning, and they've got a new sort of app that's built on top of ArcGIS Online. They're using REST.js in their new stuff as well. We've seen folks in professional services doing custom applications. We even snuck REST.js into Enterprise. That's mostly my team's doing, so we can't say that we're getting them to drink the Kool-Aid completely. Esri Canada and Esri UK, and these are only just the projects I know about. You know, folks who have picked it up, and some of them are finding bugs or helping us with documentation. They're writing demos, or they're finding a surface area, that REST API that we haven't covered yet, and contributing it. But that's been really cool to me to see, and that's just the stuff that's open source or feedback that I've gotten personally. So you can find the talk from last year on YouTube. It still, I think, covers the fundamentals, and there's some stuff that's relevant. It talks through some of the surface area of the API. We're going to try and focus on some of the stuff that's landed since then. So I think we had, I don't remember exactly how many packages we have, but we've added 5 brand new packages that didn't exist. We've had 15 releases. Our release cycle is really snappy. Basically anytime a bug fix or a new feature comes in, we just crank out another release. Just to give you an example, this slide is meant to show you, one, how still small these packages are and how minimal their footprint is, but also to show you that, because of the activity, we're seeing them blow it up a little bit. So request last year was only 2 kilobytes, and now it's almost 2.5. Auth is up at about 3 kilobytes. Some of our packages are still under a kilobyte for routing and groups and users are still sub-kilobytes. So even if you go in and grab and require in all of these packages, you're still talking about, you know, basically a gnat's eyelash worth of JavaScript code. So those are, I'm sorry, these, so yeah, this is my emojis. These are the old packages. So we had 6, now we have, oh, we have more than that though. We have five new ones, but we also have a package that's just typings for the TypeScript users. So these new packages, one of them got contributed by somebody in the crowd here, Mike Schutte from the solutions team. So they were doing work not just on feature services that already exist, but they needed to spin up new feature services and update the layer definitions on those feature services. So they created some new functionality for that. The sharing work, that came out of my team, and that was like me sort of refactoring old Ember code into something that was more shareable and utilitarian. Users came out of, I think that was a professional services request. Routing was like a kind of weekend project from somebody in professional services. And then Common is a new package that we have that blends typings and some utility methods that you'd kind of use all over the place. But that's, you know, this one's, that's still tiny because it's still more of like a work in progress than an actual thing. All right, so we want to look at some more code and talk about basically the pattern of the API, the signatures that you're going to kind of come up against and see over and over again. And there's basically 2 things that you're going to see. Pat already showed you request itself. It takes a URL, and that's mandatory. And then optionally, you can pass some request options. And so we're using TypeScript, so that's an interface as opposed to a class. And Patrick wasn't scarred by the ArcObjects days, so he wasn't afraid to name an interface, start it with an I. The rest of us, you know, might have made different decisions, but that's fine. There's something that's mandatory and some other things that give you extra control if you want to customize. That's the first and foremost pattern. We figured though there's a lot of methods calls we can make where we really only need one piece of information, and we might not even need you to tell us what the URL is. A lot of times we can figure it out ourselves. So when to execute a method and make a call to the REST API, if we only need one piece of information from you, whether it's a string or a Boolean or whatever, that's the first argument that you'll pass to the method, and that's all you have to pass. And you'll still get the option to pass through request options if you want to. So here's an example where we know the URL. We don't know the URL of your feature layer, but if you tell it to us, we can go fetch the metadata, the layer definition for that feature service. So, you know, it looks much like request, right? You pass the URL, you get the response. If you want to use a get instead of a post, if you need to pass authentication because it's secure, if there's extra parameters you want to pass, you can do that, but it's only optional. And just to echo what Pat said, we use post by default. If you don't want to use a post, you have to say that you want to use a get. And you know, back in the day when I worked in tech support and the JavaScript API, it was like CORS was still coming around. And the max length of a URL could only be 2,000 characters, and it was like you only switch to a post if you have to. But those days are over. Browsers don't really, you know, those issues are not as big a deal. Also, in this library, we don't really do anything to help you make a request that's gonna, you know, have a geometry with a densified curve that blows you up. So we use post by default just because it's simpler. And another reason we do that is because in the REST API, all operations support post, and actually many methods only support post. Some support both, but post is a guarantee.
Universal.
And get is you might be able to get. There are methods here in our API where we hit another endpoint and we know it supports get and get's the semantic thing to do, so we do it internally. But request, you know, defaults to a post. So that's the pattern number 1. Luckily, there's only 2 patterns to memorize today. If we need, in order to do anything, we need 2 different pieces of information from you at a minimum. It could be maybe even more. Rather than have X number of arguments and you supply all the arguments that you have and leave blank spaces for the ones that you don't, we use an object instead. So there's only one argument that you pass, and it's a JSON object literal with the props that you need to pass, and that varies method by method. But this pattern we call extending request options. So if you have a feature service and there's some features in there that you want to blow away, you need to know, one, the URL of that feature service, because we can't figure it out for you, and two, we need to know the object IDs at a minimum if the service allows anonymous edits, right? So here we pass a JSON object literal. I'm using like, ES6 or whatever, so because the variable name matches the prop name, I'm just passing it once, but that's one prop, and object IDs is a second prop. So I'll show you an example though. I think it's important to see what this looks like in the docs. I'm full screen, but he shared the link before. It's on GitHub, and we host the doc on GitHub Pages. The website has a homepage, and there's basically two components. There's the API reference and the guides. In the API reference for delete features, we got a little handy search. You can see that the delete features method lives inside the REST feature service package alongside query operations. So when we originally came up with this package, we only did the query stuff. And it was a customer that within like a month said, I want to do some add, update, deletes. And I said, well, you can do it with requests, and here's how it looks with requests. And he not only did that, but he contributed back some new wrapper methods. And we worked through the way that these signatures should look, I think probably in the midst of that pull request. So here's a code snippet where you import delete features and you use it. And this is courtesy of the inimitable Patrick Arlt. Up until recently, you had to click on I delete features request options in order to see all of the props that you needed to pass. So you're like traversing the documentation, and that was kind of the developer experience for that wasn't as good. And I didn't understand how to use his static site builder to get that done, because all of this code is generated from the actual source code and typedoc. And then we create a really gnarly JSON object that is then parsed by another open source project called Acetate in order to actually render the site. And then every time anybody makes a pull request with a typo fix or a new feature, when we merge it to master, the doc site gets rebuilt and it gets pushed up to the live site like automatically. So the new thing that I'm probably more excited than you are about is this whole on this page showing us the available request options for delete features. And the good news is you can see everything in one place. The bad news is right now we still alphabetize these props. And what we'd like to do, we'd be happy to get a pull request, but I think this is probably going to be one that lands on me. It would be nicer, obviously, if we had the required parameters up top, and then if there was a required inherited parameter, and then the optional parameters, and then the optional inherited parameters. But right now it's just alphabetized. So here you have a tag, you can see what's optional, but you get all the way down here to object IDs, and almost all the way down to URL before you see. These are the two things I have to pass. We're trying to do a really good job with the snippets to show what you need to pass, so you don't even necessarily need to dig into the API reference, but it's good to know not only what you need to do, but what other options you have. And here, we've got, because we extended iRequest options, there's a whole bunch of other stuff that we can pass if we want to. If we have a different spatial reference, or some of these are going to not be relevant because they're request options, but rollback on failure, some of these idiosyncratic optional params from REST, they're bubbled up and available as well. And params always gives you the option to pass whatever you want. So that is if two pieces of information are required. Now I'm going to switch gear and talk about items. So that was an example where we were dealing with the REST service from ArcGIS Server, but we weren't really dealing with Enterprise or ArcGIS Online, the whole content management system and users and groups and items. So I'm going to switch gears now. We'll talk about how you can deal with items either in ArcGIS Online or ArcGIS Enterprise. This is another example where in order to change who can access an item, we need more than one piece of information from you. We don't need a URL, but we need to know the ID of the item that you want to modify. We need to know what access level you want to set. You can either make it public, you can make it shared with the organization, or you can make it private. And then no matter what, we need authentication from you because nobody can update the sharing settings for an item without being logged in and having appropriate credentials. So here's an example of, you saw what the code looks like. This is in ArcGIS Online. I'm sure most of you have clicked this button, maybe not everybody, but there's a modal dialog here that lets you toggle through who should access this thing. If you want to make it available to everyone, automatically it's going to be shared with the org. You click OK. Under the hood, ArcGIS Online eats its own dog food. It hits its own REST API and makes that call and passes along your authentication from when you signed into ArcGIS Online. If there was no such thing as ArcGIS REST, you could still do all this with stuff Pat showed you at the beginning with fetch or XML HTTP requests. You'd have to know what the URL looks like, and the way we document this is a little, I'd say, obtuse or cryptic, because we document it once and the URL is going to be different. If you're in ArcGIS Online, it's one URL. If you're in Enterprise, it's going to be another URL. And when you're the item owner, you can use a different URL than somebody else. Now we get down into some of the contextual doc that tells you all the things that are available. You see all the options, the request parameters that are affiliated with this. So we take something that's, a little overwhelming unless you're a patient person, and we try to make it more approachable via a couple of required parameters. So we try to keep the developer experience as simple as we can, and sometimes it's simple. We make the call under the hood and you get the response back. The whole thing is simple most of the time. But there are some cases where the underlying logic actually is a little bit complicated, but we just try to hide it. So when it comes to sharing, I'd say that's some of the most idiosyncratic behavior that I've seen in the REST API. When you want to share an item with a group, when you go to share that item the first time, the response will be item shared with an array of groups. Great, I feel like I was successful. If you happen to make that call again and share that item with the group again, you'll get a response that says, not shared with this group. And it's true, but it's a different response than you got the first time. So I think they call this deterministic, a non-deterministic response. So ArcGIS Online is telling you the state of things as they are now, as opposed to the result of what you wanted to do. So in a case like sharing, I showed you set item access. That's everybody, the org or the person. There's also, we separated out the group sharing because we felt like it was a little bit more digestible. This is the logic under the hood when you say you want to share with a group. Internally, we abstract away or hide a lot of work from you that goes into making sure that you'll get a deterministic response and that it'll actually work or blow up the way it should. So here, a utility method underneath called change group sharing expects those request options. And the first thing that we do is say, we need to know who the username is and we need to know who the owner is, because you can make this call as a ArcGIS Online administrator or as the actual item owner. And this we do in Hubland, where we do some juggling and acrobatics with content on behalf of somebody else. This might be overkill for you. If so, bear with me if it's tedious, but I think this is a good way to sort of get into the weeds for people that want to, or at least let you know that you can breathe a sigh of relief if you don't have to sort of deal with the details. The first thing we have to do is we have to make a web request and get some metadata about the user to determine whether they're an org admin or not. So we ask that, and then we get that information back, and we'll use that in a little bit. The next thing we do is we say, is this item already shared with the group? So we make another request. So we kind of have a cascade of REST requests that go under the hood. And we say, for this item, tell me what groups it's already shared with. And we get that answer about whether it was already shared. If it is already shared, we short circuit and we send back a response that mimics the same structure that the REST response was, and we give you a little indicator that say that we took a shortcut, and you're done. We resolve the promise. And the cool thing about TypeScript here is we can define typings to really get control. You can get IntelliSense, and there's a lot of benefit to using TypeScript. And because we compile it to other clients, if you don't use TypeScript or you don't want to, you don't have to. It's like an opt-in thing. If we can't short circuit because it's not already shared, the next thing we need to do is say, this user, we have to check whether they're a member of the group, because some random person in the organization is not allowed to share an item with the group just because they own it. They only get to share the item with the group if they own the group or they're an administrator of the group, Or if the group is of the type that allows everybody inside the group to make edits, then there's another case for that. So you can kind of follow me that we can throw errors, so reject your promise if you're not allowed because you're not a member. And then we get back to the point where we check whether it is the owner is the same person as the user that's actually making the request. If so, we use the raw item request URL. If not, we use the other item request URL. And at the very end, we pass back this response. And here we've got a utility function internal that says, if it's ArcGIS Online, great. If the person passed authentication that tells us they're on ArcGIS Enterprise, we're going to dig out and construct the appropriate URL for them. So here, a lot of stuff happens. And this is all before we even make the call to do the sharing. Finally, we actually do the sharing and then introspect the response, and we pass along the error if there was an error, or we return the response of the response. So that's, I'm not trying to be convoluted. Most of the underlying logic of our API is not that complicated, but that's as complicated as it can get. But the point of it is, if you want to worry about that kind of thing, that's great. And if you don't, the reason we wrote it is so that you don't have to.
So I want to talk about authentication. You've kind of seen a lot of that getting passed around as an option, but we haven't really talked too much about it. We encapsulate authentication as an object called user session. There's also a similar app session which corresponds with the app logins, but user session is what you're going to be using if you're interacting with Enterprise and Portal and most servers. So there's a couple types. There's a couple ways you can authenticate with user session. The simplest one is to just enter your username and password directly in. You could be doing this if you're making a CLI app and you just want the CLI to go hit your Enterprise. If you're working on Enterprise, you can pass your custom portal URL as an option to the session, and then subsequent requests will use that portal URL. Internally, user session keeps track of everything. So it keeps track of when your token expires and automatically will request a new token when it expires, and then update all of that logic internally. So you're always going to be using a fresh token. And it also manages tokens for your federated servers, so the servers that are federated also get the appropriate tokens. And in ArcGIS Online, we actually shortcut that because ArcGIS Online knows it can trust every other server that's also on ArcGIS Online. So it actually saves you some round trips on the federation if you're using Online. So this is generally what it would look like. You have a user session, and you would pass it as the authentication option, and then that would use that same token again. So I'm going to pass it back to you. That's just real quick in authentication. I'm going to turn it back to John for another fun demo.
So we'll get a little more in depth on OAuth. The OAuth flow is kind of the recommended browser users way to allow users to sign in, but we figured it'd make more sense live in a demo than to just kind of talk through it. We showed you a bunch of code, but it's all been kind of static, and I could appreciate if that's a little hard to sort of stay interested in. So Patrick mentioned before that the Python API has Jupyter Notebooks, and we don't have Jupyter Notebooks, and I thought, well, that's kind of unfortunate. I wish we had Jupyter Notebooks too. So I wrote this thing, and the rest of this presentation is basically crazy places that you can run REST.js. This is something called Observable. So this is a web service that was created by the guy that originally authored D3. And there's a talk from a guy named Brett Victor called Inventing on Principle. And the idea is that the more closely connected people are to what they're creating, and immediately, the more creative they can be and the more they can accomplish. So much like a Jupyter Notebook, we have this sort of combination of some code and some text and some explanatory stuff, but this is executing all the time. So here's an example where I'm using the suggest method from our geocoding package, and suggest, in order to get a suggestion for an address, all we really need from you is a string. As I type in Palm Springs, California, you can see an input box where I'm dynamically typing. You can see what the code looks like to actually execute that promise, and you can see the results displayed in a text box. So I felt like this is just kind of more fun and a more interesting way to play around with the API than to just look at text snippets. So here there's some methods that we snuck in here to make, architect make sure all this thing works. But this example of one parameter that's mandatory, and that's all you have to pass. We move down to the section where if you want to get a little more control over suggest, you can say, well, I only want to get, I want to get 5 suggestions instead of the default, and I want to only search for results in the United States and Japan. I think I was like using Disneyland as my example here. So by default, we got Disneyland, but then if I turn off Disneyland and say I've got France and Japan, now I see I've got results in another country. And same thing, I'm kind of on the fly transcribing what this code would look like, but clicking buttons and saying, okay, I want to post instead of get. I guess I'd have to show you the browser tools to make you convinced that that's actually having an effect. But playing with buttons is more fun than writing code, right? So this is that bit. I'm going to stay. There's a whole little thing on authentication here, but I think it's probably better that we move into the next demo. But that's us getting to pretend like we have a Jupyter notebook, even though that we don't. I've got another demo that I'll also make really quick. So we're going to talk through what it looks like to consume the API in different JavaScript land, whether you're in Node or JavaScript, you use React or Angular or whatever. So the most accessible entry point is always to just use a CDN and load a library and not really have any JavaScript bundler or compile situation. So here's an example of an app that I wrote really quickly. Do we need, maybe we can see in the network traffic what the URL of the app is. Here we go. So my application is, it's hosted right alongside the rest of the slides, but this is a bike lanes application that takes an app ID. So an app is a type of item in ArcGIS Online. This is Esri Leaflet is another project that we worked on, but I wanted to sort of use Leaflet and use REST JS at the same time and just use the CDN and not worry about bundling everything together. So if we look at the code here, we've got our trusty unpackage.com. We load Leaflet, we load Esri Leaflet, and then here at the bottom, I'm going to use request, and then I'm going to use items. And it's important to note that all of the packages, we've got one GitHub repo with 12 packages. The 12 packages, all get released at the same time, but they are all, they don't bundle or compile whatever they depend on. They assume that you're going to do it yourself. So if you're using items, you need request, and it's up to you to bring request along. Items doesn't package it up because if you used items and search, you'd get multiple copies of request. So here are the 2 packages, these little tiny guys. And then here we're going to use them. So we first create the map and set the base map. So this is, I wouldn't say we're lazy loading the map, but we're just actually drawing the map. And then we're going to fire off a promise. And we don't know how long it's going to take to draw this last layer, but we can at least get some user interactivity and get the map displaying. Now I use ArcGIS REST. So you've seen up until now, get item data is a method that's all on its own. When we use the CDN, we're using the UMD. This is like something that works in Dojo and it works in Vanilla.js, anywhere you're going to use it. This idea of creating a namespace for your entire library, all of the packages share this namespace, and then it's the method. So we have to remember to make sure the method names don't collide between one package and another. But this is calling that same method. We pass that item ID, so I'm digging this out of the URL as a parameter. Then I have a promise and my response. I take the value of the bike lanes, I have the URL there, and I stuff that in, I create my last layer and dig out another variable and add it to the map. So I don't know if you'd use REST.js and Leaflet at the same time. They showed some examples of maybe you'd use REST.js first, and then once you're done, then you hand off to the map. But this is a CDN demo. It's meant to be a little bit of the Wild West.
So when John and I started kind of planning for this talk, I've been using REST.js in the vector tile style editor, and part of that is I have now about 1,000 dummy vector tile layers sitting in my online account that all need to be cleaned up because they're just clogging it up a whole bunch. So one of the demos I want to do is I wrote an interactive Node script to clean up some of those items. So I'm just going to show how it runs first. So I'm going to run, make that a bit bigger. We actually don't need that. yet. So I'm going to enter my username from ArcGIS Online. I'm going to enter my password.
Nifty password hider.
And it's going to ask me for a search query. So by default, the vector tile style editor saves all the base maps with the prefix of copy of and whatever the base map you started from is. So I'm going to search for copy of. I'm going to search for vector tile services. I don't care about tags. Just give me 2. And it's actually going to execute a search in the command line, and it's going to show me I have a copy of World Street Map that I edited like 6 months ago. Do I want to delete it? And I can choose yes. It'll delete that item. It says this is a copy of light gray canvas. So that one can probably go as well. And now we're done. So it's an interactive kind of command line tool that you can just kind of use as a little bit of a dummy example. But in the inside, this is what it looks like. So in Node, we still rely on fetch, but Node doesn't ship with fetch. So when you work in Node, you need to require the isomorphic fetch library. That adds fetch as a global to Node so you can then use REST.js. That's one of the requirements. We also rely on the same thing, isomorphic form data. We need form data to send files and do different things with the REST API, so we need you to add that as well. Prompts is just a Node tool for creating those little interactive prompts on the command line. Chalk is how I did a lot of the coloring. And then you get into the REST.js stuff. So REST.js also ships as a set of common JS modules for use in Node. So we can just require them just like normal Node.js modules. In this case, we need user session for the auth, and we need 2 methods. We need search item and remove item from the REST items library. So the first step is it prompted me for authentication, right? We got a little history here. So the first thing is it asked me for my username and password. So we have an authenticate. Then once we get the session from our authenticate method, we can search for items. Once we get our items, we have a response from that search API. We keep passing our session through this whole promise chain. Then we delete items. Then we finally say we're done. So that looks like this whole chain of functions that I've got. We've got an authenticate function, we've got a search for items function, we have a delete items function, and then we have a single delete item function that I just kind of wrapped up there. So the authenticate, we have 2 prompts. We need a username and a password. This is for the prompts library. We just configure the 2 prompts that we want, and that is, we call prompts with that. It gives us a promise. And we pull out the username and password. We'll make a new user session in REST.js with that username and password. And this generates a token that we can use. We're going to call session get user. We want to get the user ID. This will actually force the authentication to work. And if we get back a self response, we actually just keep passing along the session. We know that we have a good session then. If we don't have a good session, we can check. If we got a request error, we're basically sunk. You entered an incorrect username and password. Like we can't do anything else. In that case, we just call the authenticate function again and ask you for your username and password again. And you just keep going in this infinite loop until you put in the right username and password. Eventually, that resolves with a good session, and we can continue. So that session got passed into search for items, which has 4 prompts. Right, we need search text, which was copy of. We need item types, which was vector tile service. We need item tags, which I didn't enter any. And then we need how many items do we want to get. I just picked 2, I think. We then take those prompts. We start formatting. This is all formatting the search string. We're formatting the search string to there. So that's basically turning those inputs into something that looks like this. So owner, Patrick Arl, and copy of or copy of star, which is wildcard text after it, and vector tile service. And then we just pass that to search items, and we pass authentication so it can find all the private items that I own as well. And we pass the entire session to authentication, and that'll give us a response. We can pass that response and the session onto delete items. So delete items gets the list of items from the search API. This was where I had a little bit of fun. We're doing asynchronous iteration in I don't even know what now. This is all a bit of a code snippet. If you make an object with an async iterator symbol property, you can then loop over a list of things asynchronously. So this has a next function. When that next function runs, we just get the next item off of our items array. And if there's no items, then we are finally done with the loop. And if we're not done with the loop, we delete the item. And the rest of this just looks like a for loop. So we await the next item to resolve, which is that delete feature. If we're not done yet, then we just keep getting them until we're done. And if we're finally, and every item iterates, we either delete it if I select yes, or we skip it if I select no. So each iteration of that loop runs delete item, and we pass the item info and the session. Then that just prints a bunch of stuff to the console, asks us one final question: do you want to delete the item? And if I prompt to delete the item, we call remove item with that item ID and the session, and that'll resolve, and then we can continue the loop. So that's just a quick, it's 200 lines of CLI code to kind of get a neat little script running with some interactive prompts and things like that if you want to do some management on your online portal or anything like that.
All right, so we want to go back to browser land, and we want to show you something that we didn't write, something that somebody else wrote. I saw this one on Twitter. I think it's like City of Detroit. This guy wrote this, not a React app, but a React component. So this is something that you could embed in another React application. So React's kind of the most popular game in town right now for browser frameworks. And what they wanted to do was create, this is kind of similar to what I was doing in Observable, but it's text search. And here you'll see the results are a little bit skewed or a little bit centric in a particular area. And if you look at the code here, they're using React, but they're also using some other utility libraries to debounce to make sure they're not making a request too frequently. Here in the React component, we've got just a simple call to suggest where we pass along the address from the text box, but they also pass location with a center point that I think is either in Detroit or somewhere near there, and we ask for 10 suggestions. So this is digging into the REST API for kind of some of the more optional parameters to include with what you have to pass. And then they set the state in React with the results so that they can display that group of suggestions that you can toggle through. So this is the suggest bit of it. There's also one other component where I think it's this one, where once they have a result, they take the stateful sort of candidate that they had before, and I think it's down here. No, it's up a little higher. Geocode. So they call it geo. It's up here at the top. So they handle the state change. Once an item's been selected, they take that item, and all they care about is the magic key. So I don't know if you guys have ever done auto-complete type text suggestions with a geocoder, but you get back a magic key, which is this squid-looking thing that uniquely identifies whatever the result was going to be. So you can just pass a magic key as opposed to passing a string like LAX or Disneyland and say, I only want one location, and this time then they can get that result and console log it. So this is an example of just kind of a minimal UI element that you could configure a little differently if you wanted to use it somewhere else, but it's in the React world. So instead of the CDN, we do this import syntax, which is pretty much that you'll see in, well, in Node world you're going to see require, but these are just different ways to get a hold of those methods. And I'll leave it at that because Pat's got a pretty gnarly second demo to show you.
So I wanted to do a demo as John and I were kind of talking through stuff, and he showed me a framework called Sapper. And Sapper is kind of in line with kind of a hybrid of it's a client and a server framework. So the framework works on the server side to pre-render an HTML page, serve that page to the client, and then instantaneously lay the entire interactive experience of the app over the top of the pre-generated HTML on the server. And it seemed like it would be a really cool demo to show REST.js working in that context, because it has to work on both the server to fetch the initial data and on the client to fetch all of the subsequent data. So I came up with the idea for this web map dependency checker. So we'll sign in, and this is using a server-side sign-in flow. So I'll sign into online, and it goes back to my local server, it gets a list of my web maps, and it's incredibly fast because this is pre-generated on the server. So this HTML comes back from the server after being fetched with REST.js, and then Sapper lays it over the top of it. So if I search for something like, I know I have a plenary web map. So this is a map that I was thinking about showing in the plenary, and I decided not to. And you can see it fetched all this information about different things related to this web map. It's got 2 layers. You can see some of the links to the URLs for them. You can see what the sharing status is. You can see that the services are up. And you can see what the title of the web map was. The web map is private. And then it also loads this private web map with the JavaScript API. But the JavaScript API didn't even load until I went to this page. And it somehow managed to load this private web map because it also uses REST.js inside the JavaScript API. So it hands the session to the JavaScript API to use. I can go back and I can find, what's another one here? Let's just get to the demo. So the demo is a little wacky. I strongly would recommend going through the code because I've tried to comment it as best I could. There's a couple of things you might want to actually do this. You might want to do this for SEO because the HTML is actually rendered in the response so Google can index it. It's incredibly fast because it looks like it renders instantly because it's getting the HTML from the server. The server-based login that this shows is longer lasting than a client-side login. If you do the client-side browser-based flow, your sessions can only last a maximum of 2 weeks. In this, because it's the server side, the server gets a refresh token that you can use to just continuously refresh a session forever. You can use that same server side because you've got that permanent refresh. You could do background processing, you could do background tasks. And this is also, I tried to make this as secure as I could. So the token that the user has doesn't exist on the client at all. The client just has a cookie which is encrypted by the server, and the token doesn't live in that cookie. Instead, every time you use that secure cookie to make a request, you get the token back, and the token only exists at runtime. So the way Sapper works is I have a source folder that I can't make any bigger. There's a client.js, a server.js, some utility functions that I wrote, and then there's 2 folders for routes and components. And the way Sapper works is it runs an Express web server, and it turns all of the things in this routes folder into endpoints on that Express server. So this app has 4 API endpoints. It has auth authorize, which starts the authentication process. It has auth post sign-in, which completes the OAuth 2 process. So after I typed in my username and password, it redirected back to the app. It redirected me here. It also has a sign out. And then it has a new method that I wrote on the server called exchange token, which is if that session expires on the client at any point, the client can make a request and that secure cookie can be used to look up the session, and you can refresh the session on the server, hand it back to the client and say, sorry, your session expired, here I have a new one. So there's also then 3 endpoints. So Sapper is built on a UI library called Svelte that I'm not going to spend too much time on, but it basically, any HTML file in that routes gets turned into a Svelte component. So the index page just kind of renders that main page. There's a web maps page which rendered the list of web maps, and then there's a web maps web map ID which is keyed to any individual web map. So
We're running shy.
All right. Just to show the interesting bits, this is the encrypted session configuration. It's good to go look at this, but the most interesting piece is in here where Sapper gives every component a preload function. And preload runs on both the server and the client. So it runs on the server side before each request is served to the browser. And in this one, this is for that individual web map. You can see that we're creating a user session, and then we're grabbing a bunch of data about the web map and processing it in preload. But we're not doing this again on the server every time I navigate in the app. Instead, it's just running that exact same preload function on the client. So REST.js is running on the server. When I refresh, like this as a hard refresh, and then it's also running on the client when I click the link. So it's REST.js in 2 places in 2 different contexts, and it still works across both of them.
All right, I've got one more demo. I'm going to make it really quick. So web components is something Pat's talked about before. If you're not familiar with web components, it's just a simple page. And instead of writing a bunch of JavaScript that's buried in this page to make this work, here I've got an HTML tag with an a tag name that you've never seen before. So this idea of creating markup that wraps some custom logic and embedding that wherever you want, regardless of what framework is in place. It's something that's interesting to us on the Hub team because we have users that want to embed some functionality from Hub in a Drupal site or a WordPress site or some site that we don't have control over. So this idea that you could embed a little functionality, in this case we ask a user whether they want to follow an initiative or not to get more information. The way it works is, you could see I'm taking over the screen, but I could use social media. I think it'll work either way. What's happening behind the scenes when I follow and unfollow this. So at first I kicked off the OAuth flow and got that token back. I'm just updating this user, and all I'm doing is passing some tags. So we're using tags behind the scene the same way that you'd use tags on an item to group users together to help us sort of communicate with them. So the logic of the business logic's not too complicated. And in this case, because that was the only method I was calling, I just used requests because it was just easy enough and I didn't really need that extra wrapper. And I've seen other users doing the same thing. If they're hitting an API that they're pretty comfortable with, just using requests directly is an option too. But this is something else you can find on GitHub. There's a link here to web components. You can see it's a framework called Stencil that helps create it, and then it bundles up something that you could ship around wherever you want. Another place we've seen REST.js used is in Lambda functions. Has anybody heard of Lambda functions before? So this is something that is popular because you can put some JavaScript code up on a server that Amazon runs, and instead of having that server running all the time waiting for requests, it just spins up in response to a query. So there's a blog here. They're doing CRUD operations on a feature service. Just to give you more ideas, it was intentional for us to show you a bunch of demos that are in crazy frameworks and showing REST.js running in a lot of different places. The idea is not to just throw buzzwords at you or make you feel like you should know about a bunch of JavaScript frameworks that you never heard of. The point of this is whatever you're using, we can guarantee that we can get it to work without too much trouble. If you want to explore some new stuff, that's great. My attitude with JavaScript is to ignore most of the stuff that comes out until maybe a year and a half later. If I keep hearing the same word that it sounded like a kid would say, then maybe I start paying attention. But we're not trying to sort of be hipsters about it. In the couple of minutes left, we want to take a couple of questions, but we're looking at ideas to take this bare metal functional logic and help construct parameter builders. So if you want to string a bunch of method calls together, if that helps, there's some options for that. There's some more cases where we might take a response from ArcGIS server and decorate it. So instead of just getting a thumbnail with the relative path, we'll give you the full path of the URL and append a token if it's private. Some things like that to just make the ergonomics even better. I've got a list of stuff that would make a 2.0 release, which would still be pretty minimal in terms of breaking changes. I think it wouldn't cause people too much grief. But those are the things that are on our mind. Folks have been asking for some more ways to modify fetch behavior, but we're having all those conversations on GitHub, and we'd encourage you to jump in and talk to us there. We're all nice and fun to talk to. It's not like all open source projects, and that's something that's important to us too. But that's all we've got. Survey would be helpful if you got constructive feedback for us here, but otherwise it's getting late. But does anybody have any questions? Yeah.
So do you use something like this as a replacement for the resource proxies?
The question was, do we view something like this as a replacement for the resource proxies? I don't think personally, I don't feel like the resource proxies are that necessary anymore, unless you're doing the whole, like, you encode authentication into them. Not particularly. They're just kind of designed to help you get up and running with it. If you have the better way to do the kind of saving the authentication thing would be to do it through the developer site. If you register an app on the developer site, you can create a service proxy, which is a little different than the resource proxy, and you just use that. That'll give you a new URL that you can sub into some of the REST.js. So you don't even have to host your own proxy anymore in some cases. So, but yeah, not a direct replacement for a resource proxy. Yeah.
Is there any kind of guidelines or suggestions in terms of using this versus using JavaScript API? Or is it okay to like be mixing them in an app if you ended up in that?
Yeah, I would say that it's for sure safe to mix them. I showed an example with Leaflet. We have some demos in the GitHub repo where we juggle using the JavaScript API. The idea of a handover is pretty common. I don't know side by side why you would actually use it, but it should work. The idea is we're shipping UMDs and CommonJS modules and ES6 modules so that whether you're using TypeScript or vanilla JavaScript or use AMD, you'll always be guided towards using a compiled version of this that's just going to work. So whatever you're comfortable with will work.
Yeah, the one use case is if you kind of have if you have an application where you only have a map on very specific views. We use this on the JavaScript, or we use this on the developer side all the time. Most of our pages don't have a map because they're all about item management and doing everything else with your item and configuring things and teaching you about stuff. So we don't load the JavaScript API on every page because we don't need it. We just selectively load it on the exact places we do need it. So we can keep the page load just that much smaller and that much cleaner. This is the handover to the JavaScript API. If you have a session from REST.js, you can just call toCredential and register it with Identity Manager in the JavaScript API, and then the private resources that you access through the JavaScript API will just work. It's also we have probably better coverage for some areas of the REST API than the JS API does. And some of that deterministic logic and things like that. So depending on your exact use case, you might just want to pull them in together. Yeah.
Is the inverse of line 39 available?
The inverse is also available. Yeah, there's a from credential as well. Like if you have a JavaScript API.
Which we did that in the sake of symmetry, but it makes a lot more sense to lazy load the JavaScript API than it does to lazy load REST.js, but it's there. We aim to please. Anybody else? Well, thanks so much for coming. We look forward to seeing the stuff that you guys build.
Thank you.